For many years now, we have been doing work with ultralight structures. The application that we've been focusing on a lot is levitation. Can we make these things fly using nothing but light? So we take our ultra-thin structures, configure them in a certain way that maximizes the flying ability, and then shine light on them, and usually they take off. It's been around as a physical phenomenon that affects microscopic particles. So if you have microscopic particles in the air, in the atmosphere, and then you have light incident on them, those particles often move either towards the light or away from the light depending on their properties. What we started doing is looking at whether we can make photophoresis work for structures that you can hold in your hands, and now we're up to about 8 centimeter structures, even though we haven't played with payloads yet, carrying a small camera or carrying a small sensors. That's what we imagine this technology being used for in the future. Our basic process is as follows, and the best analogy that I have is that of a helicopter. So it has blades that push the air down to create a downward jet. And then by the laws of physics, there should be an equal and opposite reaction force that pushes the helicopter up. In our plates, we have the same outcome, but the way we create that jet is quite different. It doesn't actually involve any movement at all. The movement of the air is instead created by temperature differences. So if the temperature is hotter on the bottom of our plate than it is on the top, it will create a downward jet through a process that's called thermal creep. We have channels through our plates, and eventually that air flows downward through those channels and comes out as a jet. And then, just like in a helicopter, you get the lift force, and potentially you can also make it maneuver, although we're not there yet. There are 2 different materials that we have used. The first one is what we call nanocardboard, and it is 2 very thin plates of aluminum oxide connected by channels. The other material is mylar that is coated on one side with carbon nanotubes, and that allows you to create a difference in properties between the top side and the bottom side. It's not quite the temperature in this case. It's something called a thermal accommodation coefficient, but it has the same effect. Whatever small drones are used for right now, as long as we can support enough payloads, you could do similar things. Most of it is probably flying around and taking pictures or sensing some chemical concentration that may be important. If you have a persistent drone that can fly for many hours during the whole day, for example, rather than the 30 minutes or so that is typical right now, you could access new applications that are hard to identify at this point. Our hope eventually is to create a new mechanism of flight that can be useful either in the mesosphere or here closer to the Earth's surface. Potentially there could be applications on other planets too, so Mars' atmosphere is very rarefied. So one day if we want to make things fly on top of Mount Olympus, which is the tallest mountain on Mars, the helicopters are probably not going to work just because the air becomes very, very rare, and just like on Earth, you won't be able to create enough lift. But overall, we just want to explore this mechanism of flight. I'm hoping that people from other backgrounds can see potential applications in areas that I know nothing about.